Okay. So we'll start. I think last time the assignment I gave was slightly difficult. I'll cover how you did it and if you are able to get the answer. If not, I'll discuss how to do it after this class. But let's get ahead with class number 4. Today we're going to try look about. Dive into the topic of type conversions. So we learned about types in Python, like integer is a type, float is another type, string is a type, um, and list is a type, and there are other types. So we want to see if we can change types, and Python has something called implicit type conversion, because if you want to add 11 and 3.14, in math, if you just say 11 plus 3.14, you'll get an answer. But a lot of programming languages, because this one is an integer and this one is actually a float. So if I actually type print of type of...
Sir?
Yes?
Hi Ananta, your screen will be
not visible screen.
One. Okay. I'm sorry about that. So this one, you can see it now, right?
Yes, sir.
Okay. So this one is an integer and this one is a float. So if I print the type of this, and the type of this, it will tell me class float and class int. Gotta use Python 3.8. So it throws the class int and float. Like what happens when I add these two, right? What will this new number be? So Python, what it does is it does an implicit conversion. What implicit means is I'm not telling Python what to do. I'm not telling you convert this to a float, convert this to an integer and add this to this integer, or I'm not telling convert this to a float and add this to the float and this becomes a new float. I'm not really asking for that. But implicitly, that means that without me telling Python to do something, Python does it. So that's called a implicit type conversion. So in this case, what happens is essentially this number gets converted from 11 to 11.0 to a float, and then it gets added to 3.14, so it becomes 14.14. And if you look at this, the num new becomes data type class float. So that's called implicit type conversion. Another example of that is even when you're adding like a integer or a float number to a string, and then you try to add it. Let's see what happens. Because it's implicit, that means we have not really said. So there are two ways to do this, right? So one is I can ask Python to convert this to a string. Equal to so I'm converting the int to a string, and then I'm adding the number string. So this is a way of explicit type conversion. So this one I'm trying to change it and then do it. This is called explicit, which I'm going to cover a little later. But if I do that, then Python knows that it has to convert this to a string and then add it. So it will do it certain way. But if we don't do it this way, Python has no way of implicitly converting an integer to a string or a string to an integer, and then doing it back. So it doesn't know how to do that. So if I actually run this, that would I believe throw an error, because it doesn't add, it is not able to add an integer and a string. But say you want to do it explicitly, that means you want to say what you want it to do. Say for example, I want to say convert it to a string and then add it, or let me do that again, or I want to convert both to an integer and then store it. So these two things means I'm actually specifying what to do, and then Python understands that in this case converts the integer to string and adds to string. In this case it converts both to string to integer and adds the numbers. So that's what we're asking it to do. So what will happen is, in this case it added the integers 11 and 3, so we got 14. In this case it added the string 11 and the string 3, so it became 1 1 3, so it becomes appended with each other. So that is the difference between these two. And at the end of like if you check the type of this, it will be a string, while the type of the other one would be int. So the first one is a string. These two are ordered differently. So the string one is a string and the int one is an int. So that's where we get into explicit type conversion. So whenever we want to explicitly convert, there are certain functions to do it. I started using it. So this function, str function, this int function, those are things that would come in at this section. So let me move this up. So here we started using the explicit type conversion function methods. So this one is the explicit type conversion method. This is the explicit type conversion method. That means we are telling, explicit means we are actually telling Python what to do. So we are telling Python to change this from an integer to a string. And we're telling Python to change this from an int, from a string to an integer. So we'll see other cases where we do like explicit type conversion. Here, if you see, there's a method called chr that converts a number into its ASCII value. So when you deal with multiple languages, or when you deal with any large text, like some Word document or some PDF file with a lot of language written on it, say a book in a PDF file. So when you deal with all that, we'll have to deal with a lot of ASCII characters, not just the A, B, C, 1, 2, 3 numbers that we deal with. They could also be like special characters that we deal with, not just periods. So it's not just the dollar symbol, not just the typical things that you see on your keyboard. Say you want to deal with other values that have ASCII characters, but not really the ones that you see on your keyboard. So you definitely need to have access to the ASCII library, and ASCII is just a convention. So if you give a number, it has a corresponding library where you can find the values of it. So if I go in and Google if I go ahead and Google ASCII values, so I will get a table that looks like this. So this is if you look at this is the decimal value, like 13 corresponds to a carriage return, that is an enter key, and the decimal value 54 represents the number 6, and the ASCII value of 29 represents the group separator. And if you want to hit a tab, you can use the ASCII value 9. So this is like the most used ASCII values. There are much more than this. So I should probably go for this chart, which probably goes way beyond the 127. So these are called extended ASCII characters. So if you want to type in this, which is a Latin capital letter AE, so you use that. Like if you want to write the Latin capital letter E with a grave, then you write this. So when you're writing in different like languages, you definitely need all these things, right? So to understand why we use ASCII, I just brought you here. So there are a lot of like, you want to use a yuan sign, you want to use other things, so you can use that all there. So that is one reason why we use the ASCII values. And when we have ASCII values, what we do is we convert a number to an ASCII value. We convert the value back to an ASCII number. So we can do that things. So we use the CHR function to convert a number back to its ASCII value. For example, here 67 is actually a C. So if you go here, 63, 67 is actually a C. 67 maps to a C. So if I go here and convert it, and I convert the C back to a ASCII value, so I get that number back. So I can also try, say, 74, which I believe is a J, and I can try converting. Let me try this: the dollar symbol or the percentage symbol. Percentage symbol may not. Let me think about the dollar symbol. So the dollar symbol corresponds to 36, and 74 corresponds to J. And this is more useful not for English characters like J or K, but when you use like a PDF file with like German characters or Russian characters or Chinese characters, you definitely need the extended ASCII characters. So we saw about how we convert like string into int. Now let's look at, you have a binary number. Can you convert that into int? So we have the method int covers that as well. So if you give the base and you give a string of the decimal value, the binary value. So if you have a hexadecimal, you give in 16. If you have a like base 5, you give in 5. But yeah, typically it's binary or hexadecimal. So you give the binary value 2, and then the binary value here, and then the whole thing goes under the method int. What that would do is it will convert it into a integer value. And what this would do is the same as what we saw earlier here. The int of number of string. So if the string is 3, it converts it into the integer 3. So similarly here, I'm trying to convert the string of 4 into an integer. So that would come back with integer values. And I'm not printing the type here, but the type of both of these is not a string, it's actually an integer. Okay, so similar thing with float. So we look at float. Float would convert a string. So this is a string into a floating point integer. So whether I give 12 or I give so 1.2232, so those two things get converted into float. And if I print the type of those two elements, I would actually get class float. So that's what it does. It converts a string into a float. So can we convert it back, right? Can we convert a decimal back to a string? Yes, we can do that too. So when you convert this back, it gives a string 44.23. Because the printing does not show me what type it is, I can use the type method to check that it is definitely a string. But before conversion, what was it? So before this conversion, so if I just type find the type of the number before the string conversion, that would be a float. Python also uses complex numbers. I don't think I've ever used this in real life, but theoretically, yeah, we can use, if you have 3 plus 4i, like imaginary numbers like that, we can use that as well. And to convert it, we use this method called complex. We give the real portion and the imaginary portion. We use conversions earlier. Last week when we did this. We converted a list to a tuple, tuple to a list. We did this. Those are explicit conversions as well. At that time, I didn't specifically mention that those are explicit conversions, but yeah, we have done this last week. So this is the square braces element is a list, but when you move this into a tuple method and call it, it actually turns it into a tuple. You can do the same thing with set, and I think we've seen this earlier. So we can move the list to a set. What it will do is it will remove the duplicate 12s and convert that into a set. You can convert this one string into a list. That would mean each of this element becomes a part of the list. You can convert a list of lists. So this is a list of lists. So inside this list, there are two lists. List 1, list 2. You can convert that completely into a dictionary. I think, I don't think we covered dictionary. So dictionary is a name value pair. Actually, we did cover dictionary. So, but just to remind ourselves, dictionary is a name value pair where this is a name and this is a value. Similarly, this is a name and this is a value. So where that we would use that is for, if you want to know the x coordinate and y coordinates, like of a point, and you want to use this as a dictionary. That would mean when you from the dictionary, if you want to retrieve the value of x, you'll get 2, and if you want to retrieve the value of y, you get a 4. So let me do that as well. Show you. So print d1, and if I want to print d1 of x, I can do that too. So if I want to print d1 of x, I get 2, and if I do d1 of y, I'll get a 4. So those are dictionaries. Those are like key value pairs. But this is a list of list. When I started here, I had a list of list inside list, and then that got converted into a dictionary. We can convert hexadecimal values, integers into hexadecimal values, into octal values. The endpoint will be a string. So these two are strings, but the value is actually the hexadecimal value of 12. So like 16. Let's try 9. So that gives back the hexadecimal value and the octal value for these numbers. Okay. We saw this conversion of string as well, but just to reiterate, if you want to add these two, like we saw top above, so this is a 11 and this is a 1.1 as a string. You cannot add this. Python, if you add it implicitly, if you just give int val plus string val, it will not add it. It will throw an error. Now we want to tell Python how to do it. So we convert this to a string and then add it. We can do the other way as well. We can convert this into an integer or a float and then convert it. I think one thing we missed is what happens if I convert this to an integer, right? So this is actually, even if I convert it into a number, it becomes 1.1. So if I convert it to an integer, we'll lose that decimal value .1. So okay, this is already stored in string value. So let me just do that. Let me convert this to an integer and string val. I did not run this. I don't know. It's 10. Okay, so it does not convert this. I think I misspoke. So this one does not convert it to a integer at all because it has decimal values. It does not lose the value, but it has no way of knowing how to do it. So this works. The float of string val works, but if I try int of string val, it throws me a like invalid literal because it's not able to convert 1.1 without losing the decimals into a value. Okay, the next topic we'll cover, those are expressions. So this is something obviously we have been using over the last few days, last few classes, but let's talk about how it works, how Python looks at it, what are the different expressions, what are the different operators it uses, addition, subtraction, multiplication, division. So most of those work very similar to basic math. So if you want to add two numbers, if you put the plus sign, it actually does that. But internally, Python uses something called like let's do num is equal to 100, and then num dot. So when you do this is now defined as an integer. Now if you put num dot, I get all the integer methods here. So if you look at this, it has something called Dunder Methods. So this is a little advanced topic which we'll cover, I think, class 8 or 9. So when we start our advanced topics, I think this is probably the third topic or the second topic. So within the Dunder Methods, we will go in and if we find this method called add, so Python translates this plus symbol into this add method. So this is called Dunder method. That means it has this double underscore, which is done. Double underscore becomes dunder. And then if you want to look at add, then you can do the add. If you want to actually use the negative symbol, then I think there's the sub method. And if you want to use the multiplication, then you have the, I believe it's this, or is it, yeah, I think it's this mul method. And for division, it uses probably the division mod method. So what essentially Python does is, so it calls this method. If you want to add 100 and say 50, so when we typically write like this, num plus 50, but Python, what it does is it takes the integer and calls the add method, and then enters the other number as a input. So at the end it gets 150, just like if you write this internally. Python does this. Yeah, but this is an advanced topic. We don't have to we can get back to it later, but let's get back to expression. So when we use an addition symbol, it does an addition. I'm going to go through this fast, and we'll go to the next lesson pretty quickly. When you use a subtraction, 10 minus 20, it gives a negative 10, just like normal math. Multiplication, division. So here in division, if you note, I'm giving an integer value and dividing it by another integer, but what I get back is a float. So this method, the division method, if you want to look at the division method, int, okay, we already used num, right? So num dot underscore underscore division, I think, or is it true division? So if you look at that, it takes the integer value as input, but it returns the value float. But if you look at just the division method, I'm not really sure what it does. So let me check that. Probably the division mod. Let's check that out. So it takes in the integer value and returns the tuple int and int. So what it will do is it will so if I divide 25 by 4, that means I'll get a reminder. So the remainder of 4 would be, remainder when divided by 4 would be 1. So we'll get back 4 times 6 is 24. So 6, remainder is 1. So you get that back as a tuple. So so when so if you do that as 5, then you'll get a remainder of 0. So here we get a remainder of 0. But internally, this is how, like when you do a division symbol, it I think does a true division, like we saw earlier. I don't remember the name of it, but yeah. True division, yeah, that's it. So that's what it does. Okay. So we saw division with respect to like when the number is perfectly divisible. We saw what happens when it's not perfectly divisible. We still get an integer float value. When we want to use this floor division, it's called a floor division. So this we get the smallest whole number value. So 26 divided by 5, like it does not give me 5.2, but the double slash gives me the one without the remainder. So if you want to print, if you want to add strings, so I'm adding these 3 strings. First string is my last name, next is a comma and space, the third string is my first name. So if you want to do that, Python will return back one whole string with all these values. We can multiply strings as well. What that does is, if you have name asterisk symbol 3 would replace it thrice. So we'll get 3 times. So just making it. So let me look at the next one, the percentage symbol. The percentage symbol is kind of an addition to this. So when you use this, you get just the dividend. You just get how much it divides by, without the remainder. Here, if you want to know what the remainder is, I can get that using this. And if you want to like find the power of a number, so 2 power 3 or say 10 power 3, which is pretty easy. So if you want to do 10 power 3, that is 10 times 10 times 10, which is 1000. So that we get that here. So if you want to do 10 power 5, it's 1 followed by 5 zeros, which is like 100,000, comes out here. So I mean that covers all the operators with respect to arithmetic operators. We saw multiplication, addition, division, subtraction, power, the modulus, where we get the remainder. So we saw this where we get the remainder. We saw this where we get the dividend without the remainder, double slash. So all that we saw. We also saw how we can add and multiply strings. I don't know if we can subtract strings, if that's even a possibility. Why don't we try it out? So unsupported operand. So string cannot be subtracted, obviously cannot be divided. It does not make any sense. So they are not able to like if you use a subtraction in a string, it doesn't work. The multiplication and addition works though. So and multiplication works only when you multiply it with a integer. You can't multiply it with another string or a float or anything else. Okay, so that's good. Let's go on to relational comparison operators. So this we use a lot of relational comparison operators when you write your programs to understand like logic as to like when you do your while loops, when you do your logical operators, all those times you use it. But to keep it simple, like comparison operators are just like checking whether something is greater than something, less than something, equal to something, less than or equal to something. And then all these operators, these comparison operators, either return a true or a false. So they can't return anything else. And just like other Dunder methods, like these are also part of like the Dunder ecosystem. So they have things like, I think greater than is GT. So that's how you do it. So internally Python, this is how it does it. But for us now, so if you want to see if x is greater than y, this would check whether x is greater than y. Here I'm just printing it. So this is just completely a string just for us to understand what I'm printing. So this is what actually Python is computing. So here it's computing and checking if x is greater than y. So here 5 is greater than 6. 5 is not greater than 6. So it's going to return a false here. Next, it's going to check if 5 is less than. So this is string. It's not going to work on that. So let's just work on this. It's checking if 5 is less than 6. That is true. So that's going to return a true. Same way, it's checking if this double equal to, not the single equal to, just to stop here. When I actually say x is equal to y, this is an assignment operator. What that means is the value of y is assigned to x. So any value that you give in the right side of the equation, whether you say it's 100 or if you say it's like 6, in this case when you use 1 equal to, it's an assignment operator. But when you use double equal to, you're actually checking whether those two are equal. So here So here is this equator is actually checking for checking if both values are equal. And it will again return a true or false. Here we are using 5 and 6. So in our case, x is a 5, y is a 6. So obviously these two are not equal. So it's going to return a false. Here if you see, this one is a not equal to operator, just like the earlier one, double equal to, and this one is a exclamation equal to. This is a not equal to operator, greater than equal to operator, less than equal to operator. So not equal to is going to be true, 5 is not equal to 6, 5 is greater than or equal to 6, not true, 5 is less than or equal to 6, that's true. So those are how we'll get our answers. Okay, we spoke about getting to logical operators. So let's see how we can use those. So these relational comparison operators diverse into logical operators, which is and, or, in addition to other method releases. So when we use an and, when we use an or, so those are where we use the logical operators. So there are three operators that are logical in Python: and, or, and not. So if you want to say something is not true, say if not a greater than 0, then that will be a way to say if not a greater than 0, that will be a way to say use a not. And if you want to use or, you just use two conditions: a is greater than 0 or b is greater than 0. And the difference is, as English implies, not would mean opposite of this, or means this is true or this is true. Any one is true, then we'll still be working through it. Here both have to be true for and to work. If this condition has to be met as true, a has to be greater than 0 and b has to be greater than 0. Any questions until now? Like I covered through multiple operators. Okay, good. Let's go through this is an assignment operator again. So it's assigning 2 to a. Here is an assignment operator. We are assigning 4 to b, and we go into checking whether both are positive. That is, a is positive, a is greater than 0, and b is positive, b is greater than 0. If both are positive, then it's going to print the value a times b. And if say 1 is negative, then it wouldn't check both of these, and then it will actually print 2 nothing. So if I run this, because one of it is negative, it's going to do nothing. If both of them are negative, it still is going to like do nothing, because both conditions have to be true for it to print this. So it's still going to print nothing. But when I take any condition where both are true, so b is positive and a is positive, in that scenario I'll get back a multiplication of a and b, which is 8. Okay, we'll look at the next one, which is the assignment operators. So when we did assignment operators, we've been using this since class 1. But to understand what it is, you can actually assign variables. You can also say a is equal to b as well. So that means the value of b would get assigned to a, and then you print a. So you'll actually get the same value for both. So here what we did was we assigned the value of b into a. So a becomes 2 as well. Even though we started with a as 4, here we change that value. The next thing we look at is a plus equal to b. So this is another assignment operator. What that means is it's the same as a equal to a plus b. It's just a shortcut as used. It's called a shortcut operator. So we are shortcutting writing a equal to a plus b as a equal to a plus equal to b. We typically use that in programming where when we want to increment a number by like 2 or 1, so we want to have a counter. So when we say counter plus equal to 1, so what happens is every time we want to look at a value, and if it is say even, we want to add the counter to be 1 more. So we have a list, so we go through each element, and whenever we find a even number, we add the counter by 1 more. So we keep counting that until we find the end of the list, and then we say, okay, at the end we found like 10 even numbers, right? So that for that reason we use this a lot in the code. But essentially, if you want to use this shortcut, all we're doing is a plus equal to b. Here a and b are 2, so 2 plus 2 is going to be 4. Okay, a negative equal to 2, I think you can understand. Just like this, it's the same as a equal to a minus 2. And in this, it's a multiplication operator, a equal to a times 2, a equal to a divided by 2. And if you want to do the power, I've never done this in real life, but yeah, you can use that as well. This operator is useful as well. And modulus percentage equal to 2. So we are assigning the remainder of that divided by 2 into the same a. Again, this is something I've never used as well. We have the same for floor division as well. So the next thing we need to understand is just like in math, we have the BODMAS principle, or how we look at brackets first, then calculate the multiplications and divisions, and then we look at the additions and subtractions. So in Python as well, there is something called operator precedence. So unless you're doing heavy math in Python, you're not probably going to worry about this a lot. But in data engineering where I work, like certain times we'll have to like add multiple values and then take the mean of those, like and then do a calculation where you compare with another mean. So there is some math involved. So it's better to understand the order of operations. So similar to math, like the brackets get evaluated first, then the multiplication, then the addition. So I think for this case, the output would be 6 times 2, which is 12, plus 12. So, or to do it in 3 steps, it would first evaluate this bracket, multiply 2, and then plus, and then it will evaluate the 10 plus 2 bracket, which is 12. And in the next step, it would multiply 6 and 2, which is 12, plus 12. Now it will evaluate these two, so it becomes 24. So that's the order of evaluation. So in this case as well, first the multiplication happens, then the addition happens. So same 24, I believe. Okay, or this is just showing the steps of this. That covers most of what I wanted to cover for this week. Let's now get into a little bit of like tougher questions and how to do those. And I'll also give you a sense of what we're going to cover in next class. Okay, the first for next class, right? Class number 5, we'll go through control flow. very important for programming. If statements, while statements, for loop statements. So until now we've been going through one line by line of code. These for loops, while loops, and like if else statements would help you branch, would help you repeat certain statements multiple times, check the condition, and then do it only if the condition is met and stuff like that. There is also break, continue, pass. So this is something we'll use, and we'll build a program to actually use that. So that is what we'll cover next week. So for this week, let's get into a slightly difficult problem to solve, and then we'll try to solve that. And we'll try to get an assignment done. Before that, let me start with last week's assignment. So did you guys try out last week's assignment? Prem, were you able to do it, or do you want me to show how to do it?
Yes, sir. I find out the conditions in palindrome, sir.
Oh, you found the conditions of
Yes,
how to check with the
palindrome.
palindrome?
Yes, sir. S double equal to S of minus 1.
Okay. So your string is, say, A, B, N, J. So you're saying S double equal to S of minus 1,
S minus S of minus 1, sir. Other,
like this?
sir, the 4 dot, I don't know the words, sir.
Okay, like this.
Uh,
Like this? Okay.
One more. Yes, sir.
So you're checking that? Okay. Okay, let's see what.
Yes.
Yeah. So okay, let's do it in a simple way. So yeah, A, B, C, D, E, F, right? So when I do that and I use this operator, so what happens is it completely reverses this string. So this what you did is perfectly all right. Yeah, but what you essentially did was you reversed this string using this this concept that we studied last time. So it essentially has a starting point, end point, and this one specifies that we're going to start from the end. So and then what you did was you checked if s is equal to this, and if it is equal,
Yes, sir.
then you said print it is a palindrome.
Palindrome.
Yeah. Okay. So this is what you did, and then obviously for A, B, C, D, E, F, it's not going to be a palindrome. But if you do B, D, C, B, A, I believe that's going to be a palindrome. So it returns out the correct values. Okay. So that's pretty good. So
Sir, and how to write in the constraints less than or equal to S length, less than or equal to 2 star 105?
less than or equal to, so if you want to check the length,
Yes, sir.
if you check length len of
Length. Yes, sir.
s, and then if you want to check
Less than 2 star 105. Less than or equal to 2 into 105. 105.
what are you checking here?
Palint. It's less.
I'm not sure what you're doing here in 2 star 105. Did I write it correctly as you said, or did I do something wrong? Okay. so so this is a very good way of doing the palindrome. He did it in one line. So let's understand how we can do this if we don't know this these operators, right? How do we do it, right? So let's think about that. So essentially S has this value. When we start with S, it has this value, and then what we want to check is we want to check if the first value of S and the last value of S are the same. So like one way of thinking about it is, so if you want to see the S of 0 and S of length of S minus 1. So to slow down, let me go here. So if I look at this, it has 3, 6, 9, 12. So length of S is going to be 12. I'm sorry, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I want to find the last value of it, then that would be S of len of S minus 1. So that would give me this value. And then if I check if the first value and the last value are same, then at least the outermost elements are fine. Then I'll just keep adding one more. At first I'll check if 0 and length of S minus 1 are same. If it's same, I'll move on to the next one. I'll add this. I'll add 1 to this and subtract 1 to this. And then I can go on to add one more and keep checking on that until these two numbers are same or they reverse each other. So if I keep going until these numbers are either the same number, so it becomes like this number and this number are same. That is at first it will be 10, 0 and 10, then it will be 1 and 9, then it will be 2 and 8, and then it will be 3 and 7. I keep going until 4 and 6, and then and when it's 5 and 5, I don't have to check it because both are the same element. If I check all this, and if it's still the same, that means we would still have a palindrome. So if we check all this and all of them are same, then that's good enough to be a palindrome. The way we check that is like, let me use a while loop or something like that. I can say while S of len of S minus I is greater than or equal to or just greater than I. Let me start with I counter as 0, and then while this length is greater, that is it's this number which I'm calculating here is always greater than this, the I. So this is I, and this is length of S minus I. Actually plus 1, so or minus 1, I'm sorry. So what I'm essentially doing here is length of s, and I here is 0. So I is going to be 0 and then minus 1. So this I'm checking if this is greater than this, and then I'm checking if s of I is equal to s of or if it's not equal to. Okay, so I will here if it doesn't so here essentially I can check if something is a palindrome. So I can do it this way. So what I'm essentially doing is I'm doing this logic. I'm doing this logic until these two numbers are same, and every time I'm checking if these two the values in this position and this position are same. I'm checking that, and then I'm getting that to this. Okay, I think before I start, I should keep increasing I plus equal to 1. Um, Before it goes to the next iteration of the while loop. So let me try that. Um, so now like for the s we have given abc, what it does is it checks each value one, the first one, and then and then the last one, the second last one, the second one, third one, and the third last one, fourth one, and the fourth last one. It keeps checking that way. That's what it does during this in this while loop. And within the while loop, we're just checking if it's equal. If it's not equal, we are returning false and we're closing this loop. If the whole while loop is completed without having any like differences, then it goes through and says this thing. So say here I want to change this f to be 5 5. Okay, that will work too. So let me change it to 5 7. And just to see how this is working, I'm going to print I'm going to print the value of I. to print the value of length of s minus 1, and then I'm going to print the value of s of I, and s of these four things to see how that is working. So we see what happens is the first one, it checks the position 1 and 11, both are A. Next time it checks 1 and 10, so it increases this by 1 and decreases this by 1, and then it checks both the same. Here 2 and 9 both are same, 3 and 8 both are same, 4 and 7 both are same, but 5 and 6, these are not same. Let me change these to be alphabet so that these are easier to comprehend. So Z and let's say E or R. So these two alphabets are same at position 0 and 11, 1 and 10, these two are same, 2 and 9, these two are same. Until here everything is same, but when it comes here, it knows that it's not the same, so it prints it's not a palindrome, and then it returns the value false. So here, when I call this whole loop happens, and then I get the value false. So that's what is the traditional way of doing things. Prem did it very smart in just one line. So what he was doing is, I think we learned this operator of splicing. So we learned about splicing. So that's what like Prem has done. So slicing us, like if you slice this by -1, so what we get is the reversed value of s. So essentially he's reversed it back, and then he's checking if it is equal to s. So that's what he's checking, and here, because the reverse value is not true, it's going to get false. So whatever I did here, the whole logic returning true false, that he has done this in one line. And essentially what this does is, it's a splicing operator that reverses the string, and this is the original string. So he's checking if the original string and the reversed string are the same, and that's what a definition of palindrome is. Right? So that covers his operations. Let's look at what splicing is and what are the three operators. I think we looked at splicing when we looked at lists. So I think must be here. So slicing, what is including, what it's excluding, right? So NM, that's what we looked at. The third operator of slicing, that is what we've been using today. So Prem, any questions? Are you good with how we did it, and how you did it is good? And
Okay, sir.
did you
Sir.
ask me something about this? I didn't understand your question fully. You said something about something times something, right? 2 times 150 or something. I didn't understand that part. Is that something?
Sir, in your previous week example, sir, you give the constraints one less than or equal to s dot length printable ASCII characters.
Okay. Yeah, what I meant by that is, yeah, that's good. No, I understand what you're talking about. So when I gave you the assignment, I said this constraints, and I said this, right? Okay. Add. So in the when I gave you the question said constraints is s dot length, that is the length of s should be between 1 and 210. So the string is going to be not a very long string. It's at least one byte long. So 1 character long. Maximum is going to be 210 characters. So 2 times 105 is essentially 210. So the length of the string can be between 1 and 210. That's what this line means. So yeah, you that's okay.
Okay,
You
sir.
covered that. Yeah, you covered that. Yeah, this is just
Length.
short form to say that length can be between these numbers.
Okay, okay, sir. Understood it.
Okay, and are we good? So like can we cover the rest? Like next week we have this thing. I'll send you the assignment for this week as well after this class. Anything else we need to cover? No other doubts?
No, sir. No doubt.
Okay. Okay. Yeah, within the slicing operator, there is a special trick to use -1 to actually like reverse it in place. So that like it doesn't reverse in place; it reverses and returns that. So that is one trick that like we can use as well. We will cover next week. We'll cover through control flow and if statements. So this week as well, assignment will be as tough as last week. Next week I'll make it slightly more tougher, and then when we go to the advanced topics, we'll start doing a project as well, so that we can get the understanding of like real life usage of Python. Till now we are using kind of textbook usage, right? So but we'll start getting into that real time usage.